where we are going to discuss very important and few topics of syllabus of semester 5 BSc Nagpur University. We have planned this lecture according to the need of student. It is planned to make it very easy for student, keeping the language very simple, elaborating the thing to the simple level, to the grassroots level. And the simple theme we started this session as a simple policy: one topic in one lecture, one topic in one session. So we will not make a mess of it. We will take things very simple to make comfortable with those students those are having the biological background. Okay, so basically if we understand the things in a very simple language, it will be easy to understand, it will be easy to remember and to practice. So we will have only one topic in one session. So today's session will be Schrodinger wave equation for hydrogen atom in polar coordinate. So if I ask why it is important to learn to understand Schrodinger wave equation for the hydrogen atom, so basically it gives very important information about the actual chemical system of atom. It includes structure, it includes energy. So if we elaborate the word structure, it gives details like some orbital electron density and the atomic orbital. So if we understand the Schrodinger wave equation for hydrogen atom in polar coordinate, we can have the real information of energy, its structure, electron density of atomic and shape of atomic orbital. So if we proceed with this system, we can elaborate in the later lectures that why these are very important for this, for understanding the chemical system. So first thing is why hydrogen is chosen. Very simple and very grassroots level question. Why hydrogen is chosen? It is chosen because it is a very simple system. It consists of, if we elaborate, or if we take in a nutshell, one electron one proton system. So if we could understand the hydrogen system, we can use this information to understand some simple to the complex system. That's why hydrogen atom is elaborated with respect to its wave function in this topic. So this is the visualized structure. That's one proton is there in the nucleus, an electron is revolving around. So it becomes very easy to understand. And if we can understand the simple system by using this information, by using this knowledge, we can elaborate the complex system. Now next one is, if we see the Schrodinger wave equation, this is very classical equation that we learn from our intermediate 12th standard to the first and second year. That this says everything about the atom. It take care of its Cartesian coordinate x, y, z. These are nothing but the place dimension, its mass, and the energy and potential. So this gives overall information of the particle or the wave. Now I'm using two words, particle and wave. Basically, according to the different uh, evolvement or different development in the quantum chemistry, the particle is having the dual nature. It also behave as a particle, it also behave as a wave. That's why we can see here both parameter of particle as well as wave. This is the mass and this is the Planck's constant. Mass, particle behavior, and Planck's constant is a wave behavior. Now, if we want to determine the polar coordinate of hydrogen, we have to consider the mass of electron as a reduced mass. This is required because if we consider the mass of electron and mass of proton, they are having a lot of difference. So we cannot take the exact mass of electron, we have to consider its reduced mass. Now its reduced mass is determined by a formula: reduced mass mu is equals to mn into me divided by mn plus me, where mn is the mass of nucleus and me is a mass of electron. Now if we could change the the mass of electron to the reduced mass. Similarly, we have to replace the potential, that is V, into its different form, where we consider the charge of electron and the distance of electron from its nucleus. So it is given by V equals to minus E square by R. Now we have two terms, reduced mass and the potential. And if we put this in the Schrodinger version, equation becomes this. You can see here, in the first we replace the mass with the reduced mass and potential with E square by R. Now this is the equation that we are going to use to understand in terms of the polar coordinate. Okay, so the question first comes, what is the need of converting the Cartesian coordinate to the polar coordinate? First, we need to understand what is the Cartesian coordinate. Cartesian coordinates is nothing but the places x, y, z in a 3D graph. And the polar coordinate consists of radial and the angular dimension that covers the 360 angle. And if we go back in the historical evidences from where we evolve in the quantum chemistry, we consider this atom as a 360, a rigid sphere. So to understand the spherical nature of the chemical system, in this case hydrogen, we have to consider the polar coordinate to get its exact information. That's why we need to convert the polar coordinate to the we need to convert the Cartesian coordinate to the polar coordinate. Now again, if you can visualize it, so this is the particle, that is the electron placed in xyz. Now if we assume the nucleus as the origin and electron in the xyz place, this will be the Cartesian coordinate. You can see here the particle is placed with some coordinate xyz in the xyz plane. Now what is the meaning to convert the Cartesian coordinate to the polar coordinate? Just we have to convert this Cartesian coordinate through to a 3D sphere where electron is moving like this. Now the xyz coordinate, that is Cartesian coordinate, and the polar coordinate have different level of information. This gives the overall energy as well as the position of the particle or the chemical system, whereas it gives the angular momentum or the radial things related to the structure. So it gives more precise information as compared to the Cartesian coordinate. Now let's proceed how to determine it. First, consider a particle P with having reduced mass and xyz dimension. It is placed in the xy Cartesian coordinate. Now connect this with nucleus. Now this is the distance of the particle with the nucleus and consider this as a r. Now if I want to determine what is the polar coordinate of the z-axis, okay, how the particle is aligned with the z-axis, I need to have some angle. This is the angle of particle with the z-axis, this is theta. Now how to determine how the particle is aligned with the z-axis? Okay, so this z-axis and this particle, we will plot a perpendicular, that is pz, to the z-axis. So this is the perpendicular. Okay, so this is the perpendicular and we have this equation. Now if we consider the pt perpendicular to the z-axis, the angle, that is zop will be theta. If I want to determine the dimension of OT and I know the angle of this right angle triangle, I am saying this right angle triangle because the PT is perpendicular to z axis. So this will be the opposite side of this 90-degree, means this is hypotenuse. So what suggests the cosine? Cosine is the adjacent side divided by the hypotenuse. So adjacent side will be OT divided by OP, means Z divided by R. If I rearrange it, I get this z equals to r dot cos theta. Now this is the polar coordinate for the z-axis. I will repeat once again. To determine the polar coordinate for this z-axis, I need to draw a line from point to this nucleus. The angle will be theta. Then I will draw a perpendicular pt to the z-axis. This angle will be 90 and theta will be ZOP. If I know the cosine of this angle, it will be adjacent upon hypotenuse. So OT by OP, OT by OP, Z by R equals to, or if we can rearrange it, Z equals to R cos theta. It is very simple. Now, how we determine it? First, we consider how the particle is taking the angle with the nucleus, and then we determine it. If we determine for the z, similarly we can determine for the this x and for the y. For that we need to extrapolate point p to the xyz plane. Now this will be required later. Okay, sine theta will be opposite by hypotenuse. Opposite of this angle is tz, opposite by this. If we rearrange it, will be r sin theta. So to determine the x coordinate and y coordinate, we need to extrapolate this point and we have to use this xy plane. Now you can see here this z axis is perpendicular to the xy plane. Now this is the connection how it reaches here. Okay, now if I connect this point which is on the xy plane with the nucleus, it will form some angle with this. Okay, and this is the phi. This is perpendicular and this is phi. So if you want to determine the coordinate for the x, just draw a point perpendicular to the x-axis, that will be p dash t dash, and angle of phi, that is t dash op, will be phi. Now my object is to determine the polar coordinate for the x-axis. So it is determined like this. First we extrapolated this point to the xy plane, that comes to be p dash. Then draw a perpendicular to the x-axis and connect this point to the nucleus. So angle will be p dash o t dash as a phi, and this will be perpendicular. T dash p dash is perpendicular. If t dash p dash is perpendicular, the op will be hypotenuse. Now if I want to determine the polar coordinate for the ot, okay, polar coordinate for the ot, I also use once again the cosine function for this phi. For this, cosine of phi will be adjacent upon hypotenuse, means o t dash by op dash, that is this one, ot dash. Okay, ot dash divided by op dash. This is x divided by r sin theta. Why this is I sin theta? Because if we see here, the tp and the op are the opposite sides of rectangular and they will be having same dimension. So here if we rearrange it, x will be r sin theta cos phi. So here we determine the x coordinate. How we determine the coordinate? Just extrapolate this point to the xy plane as a p dash. Draw a perpendicular to this p dash t dash. Connect this p dash to the nucleus to have the phi, that is phi angle. Now if I want to determine the OT dimension, I need to use cosine of phi. Cosine of phi will be adjacent upon hypotenuse. Adjacent will be OT dash and opposite will be OP dash. OT dash equal OT dash divided by the r sin theta. If we arrange it, x will be r sin theta cos phi. And at the last, if I want to determine for the polar polar coordinate for along the y-axis, I need to draw a line perpendicular to the y-axis. This will be p dash t double dash. So this will be perpendicular. If this is perpendicular, then this will be the hypotenuse, that is OP dash. Now we know the trigonometric relation. If this is the angle, this will be phi dash. Now how to calculate? Just we have drawn a perpendicular p dash t dash to the y-axis. The angle t dash p dash o will be phi sine. Now if I want to determine the ot dash, this is exactly opposite to this phi. So which ratio take care of opposite side of the angle? It is the sine function. So sine of phi will be ot dash divided by op. ot dash divided by op. ot dash divided by op means y divided by r sine theta. If we rearrange it, y will be r sine theta phi theta. So if I want to determine the polar coordinate, just remember from the point we have to determine perpendicular to the different Cartesian coordinate. If I want to determine for this z, I have determined pt as perpendicular. If I want to determine for this x, p dash t dash perpendicular to the x. Similarly for this y, p dash t double dash. So by using some simple conversion of sine cosine, I could convert this to the polar coordinate, and this is the pictorial representation of Cartesian coordinate to the polar coordinate. Now this particle is revolving 360 to the nucleus, and this is the much nearer explanation to the spherical nature of atom. So by using some trigonometric function, I can easily convert this Cartesian coordinate to the polar coordinate, and we have now x equals to r sine theta cos phi, y equals to r sine theta sine phi, and z equals to r cos theta. Now I have all the point converted to the polar coordinate. I just need to put these values in the Schrodinger wave equation. So this is the Schrodinger wave equation where I can directly put this value in equation number 1 to get this one. Students, as far the Nagpur University is concerned, we need to remember this equation for the examination purpose, and it is very easy to you. If you practice, you can easily remember it. Now you can see here the all the Cartesian coordinate x, y, z are replaced by r, cos, theta, and phi. Now this is the coordinate, and it gives more exact information of hydrogen system in a polar or. So this is a simple topic that we covered in this lecture. We convert the Cartesian coordinate to the polar coordinate, and in the university examination the question will be explain or write the Schrodinger wave equation in the polar coordinate. Now the importance with respect to our next classes, it is very important because it gives information with respect to radial and the angular wave function. Radial means r and angular means theta and phi. This will be taken in the next class. We can easily determine the radial and the angular wave function with by using the equation of the Schrodinger. Then along with the radial and the angular wave function, we can determine the energy of hydrogen atom. So for this class, we determine the Schrodinger wave equation in polar coordinate for the hydrogen system. Very important with respect to the various properties that we are going to take in the next class. Our session will be on radial and the angular wave equation and the energy of hydrogen atom, and it will be base of quantum number in the next online session. So in the next section, the schedule will be in the next class. In the next slide, we are going to explain the we are going to derive the radial and the angular wave function. We are going to derive the energy of hydrogen. Thank you so much for the pleasant learning. We are going to use this platform for knowing the quantum system in a more easier way, in a more lucid and the simple language. I hope a good participation with your questions on my this channel, as well as on my WhatsApp number and my email. So see you in the next session. So this is the schedule. Our next class will be on Wednesday, morning hours 8:30 to 9:30. Again, I will take only one topic in one session, and next will be on Saturday 24th at same time, one topic. So in this two lecture we will cover the quantum chemistry of semester 5, prescribed by Nagpur University. Now, for this next class, I need to join you onto Google Meet. That's why we will have more easy interaction. We can have the question, we can have the queries to be solved. We will interact each other on the Google Meet. So you have to register yourself on this WhatsApp number, and you can mail your request on my email ID. So my WhatsApp number as well as the email ID is given on this slide. So here I am signing off, and I would like to see uh, the student, maximum student for this participation, and and we will explain all these things which are mathematical more or less with respect to the chemical aspect. So it will be easy for those or the feel burden with the physical chemistry. They have some anxiety with the physical chemistry. So I register here. You will have the maximum benefit. Once again, thank you so much. Please, patient listening. Sign off. Bye. Thank you so much.